In this video, we are going to discuss about buck converters. So, it is nothing but a DC to DC converter. So, here my input signal is V1 and output I am going to get it at the resistance, that is V2. It has a switch, the transistors act as a switch, and you have a diode followed by a inductor and a capacitor. So this usually, if the V1 is 10 means you will get V2 is lesser than V1. So that is why it is called as buck converter. So I can tell V1 is always greater than V2. So normally it does step down, okay, DC to DC converter. So let me assume the switch is opened for this second, okay, 0 to DTS. So till 0 to DTS, the Q1 transistor is on, okay, and from DTS to TS it is off, okay. So the Q is off for this duration. So what is the total duration? So total duration T is equal to TS. Then so what is the on time? So I can write T is equal to T on plus T off, right? So what is it? Q on time? Q on time is DTS and Q off time is TS minus DTS. So that is nothing but TS, right? So what is D? So I can write D. D is nothing but a duty cycle. So what is D? D is equal to T on time plus divide by T on plus T off. So what is T on time? T on time here is DTS, and what is total time? Total time is nothing but TS. So this is nothing but T. So consider when the switch is on. If the switch is on, the diode is reverse bias. So diode is reverse bias means when Q is on, diode is reverse biased, right? So it is open circuited. So therefore it is open circuit. Okay. So if it is open circuit means the current will flow in this direction. So if the current is flowing in this direction means what is the value of IL? IL is, so I can write this I1 is equal to IL plus the current through this one. So I can write the voltage across the inductance. So the voltage across the inductance is equal to V1 minus V2, right? When the Q is on. So during that time the inductance get charged, okay. So the current get increased, okay. The current is increasing, and during that time the voltage across the inductance is V1 minus V2. So what happened when Q is off? When Q is off means, when Q is off, this is short circuited. Diode is short circuited. So therefore the current across the inductance start to decrease, right? So it start to decrease. So it start to decrease. So what is the value across this inductance? You can see during that time you have a inductance followed by a capacitance followed by a short circuited line. So this is nothing but VL and this is nothing but V2, right? So you can write VL plus V2 is equal to 0. So therefore VL is equal to minus V2. So you will get the value of this one as minus V2. Okay. So during that time the capacitance, the current across the capacitance start to discharge, right? So I can write this is I2. So we know that IL is equal to IC plus I2. So what is the current across capacitance? IL minus I2. Okay. So this is IL minus I2. When it gets charged, when it get to discharge, it is minus IL minus I2. So this is the current across the capacitance. So let me assume this is my desired voltage. Okay, my desired voltage is, so I need to get a constant value, right? This is my desired voltage across V2. This is my desired voltage. Let me assume it is around 5 volt. If I give 6 to 7 volts means I need to get the 5 volt. So what is the current across this one? Current across this V2. So in order to get the current I2, I need to divide what is the value of I2? I2 is equal to V2 divided by RL. Okay, so that is this current. Okay, that is this current. So what is the output I will get across this one? So I need to multiply this voltage across if I want to find the value of V2. Okay, so I need to find the value of V2. So if I want to find the value of V2, so this is my desired value, but I am not getting the desired value. I'm not getting a desired value. There is a change in the V2 because of this current. Okay, so the desired values, so the obtained values. Okay, so the obtained values, so IC is minimum at this point. So if the IC is minimum at this point means I2 is greater, right? So I2 is greater, so I can write at this point. So at this point V2 is somewhere here, and you can see at this point IC value is minimum, so the IC I2 value is greater. So that is at this point. Okay, so you will get the output like this. Okay, so instead of this straight line I am getting a fluctuation, so I can write this one as equal to del V. So let us derive the derivation. So I can write the total time, that is V1 minus V2 across the inductance. Okay, so the V1 minus V2 into this is T on, right? So V1 minus V2 into T on plus minus V2 into T off. Minus V2 into T off, that is equal to 0. So I can solve this one. V1 T on minus V2 T on plus T off is equal to 0. So I can write V1 T on is equal to V2 T. T is nothing but the total time. So I can write V2. What is V2? V2 is equal to V1 T on divided by T. So this is nothing but T on divided by T is nothing but D, duty cycle. So next I need to find the value of the inductance and capacitance, right? So I can write VL is equal to DI divided by DT. Okay, so during the T on time, when T is equal to T on, what is the value of VL? During it is V1 minus V2. So it is V1 minus V2 that is equal to L del I divided by T on. So I can write what is T on. So T on is equal to L del I divided by V1 minus V2. Similarly for T off, T is equal to T off. Okay, so during that time, that is minus V2, right? Minus V2, the slope is decreasing, therefore I can write minus L del I divided by T off. So I can write T off is equal to L del I divided by V2. So we know that the total time is equal to T on plus T off. So therefore we substitute the value. So you take L di common, you will get 1 divided by V1 minus V2 plus 1 by V2. So that is equal to L del I into V2 plus V1 minus V2 divided by V1 minus V2 into V2. So on solving, so this V2 and V2 get cancelled out, you will get the value of L is equal to T into V2 V1 minus V2 divided by del I V1. So next I need to find the value of capacitance. So we know that del Q is equal to C into del V, and I can write we know that I is equal to dq by dt. So Q I can write as integration of dt. So integration of dt means the capacitance value, right? Here I am taking the capacitance value. So it is nothing but the area of the capacitance. So the area of the capacitance is this one. Okay, so this is, so if you see the this is your total time. So this is half of your total time, and this is your del I, and therefore this height is del I by 2. Therefore I can write del q is equal to 1 divided by 2, because it is in the triangle shape. 1 divided by 2 into breadth into height. Breadth is 1 by t by 2 and height is del I by 2. So I can equate C del V is equal to T into del I divided by 8. So I can write capacitance value is equal to T into del I divided by 8 del V. So del I formula from this equation I can write from the capacitance equation, from the inductance equation. Del I can write del I is equal to V1 minus V2 V2 T divided by L into V1. So I substitute this value here. So here, so if I substitute the value, I will get C is equal to T square V2 V1 minus V2 divided by 8 del V L into V1. So this V1 minus V2 I can write, I can take V1 common. If I take V1 common, I will get 1 minus V2 divided by V1. So what is V2 by V1 is D. So this V1 and V1 get cancelled out. So you will get T square V2 1 minus D divided by 8 del V L. So 1 by T is F. So I am going to substitute this as F square. Next, if you want to substitute the L value, so L value is nothing but RL divided by 2F into 1 minus D. So how it came means this del I, if this is so if this is your del I means if this is your del I means I square is equal to 2 times so 2 times the I2 is nothing but your del I. Okay, so I can write del I is equal to 2I2. Instead of del I, I am substituting 2I2. So if you solve this one, you will get 1 minus D. Okay, so what is V2 by I2? V2 by I2 is RL. You can see V2 by I2 is RL. So you can substitute 1 by T is nothing but F. So we will get L is equal to RL divided by 2F into 1 minus D. So you substitute this formula here. So on substituting, I will get C is equal to V2 divided by 4F RL del V. So that's all about the video. Thank you.